write down the laws of logic. The laws of logic. Write down all these results. 10 laws are there. Write down all the 10 laws quickly. So once you complete, you let me know. Okay.
Ma'am, the screen is not visible, ma'am.
Okay, wait for some time.
Blur, ma'am.
Ma'am, can you send a pic of it, ma'am?
Just a moment, wait. Now,
Yeah, ma'am.
now can you see properly?
The screen is not visible, ma'am.
Guys, just a moment. Wait for 2 minutes. Ready, sir? No, I'm having some problem with the document. Okay. Rohan Philip, will you please unmute your mobile?
Oh, sorry, ma'am.
Guys, I'm not able to share the scanned copy. Okay, just I'll be holding like this. Just write down quickly.
Ma'am, it's not visible, ma'am.
I'm not getting. Okay, I'll write myself only. Just copy from my book. First one, law of double negation. Law of double negation. So always for any proposition P. So this is the common word every time you have to write common sentence. For any proposition P, always negation of negation P. What is negation of negation P is always logically equivalent to? Can you tell me? What is negation of negation?
P, true.
Yes, it is P only. It is not truth or false. Negation of negation will cancel each other. Okay, so it will be P only. Second one, idempotent loss. Idempotent loss. Okay, right on. For any proposition P, PRP is logically equivalent to P. PRP means P disjunction P is always logically equivalent to P. Similarly, P and P is also logically equivalent to P. P conjunction P is also logically equivalent to P. Third one,
Ma'am, it's blur, ma'am.
I see I am
It's
having
not-
some network issue. See, I can't help anymore because I'm having some network issues. Identity loss. Identity loss. Third one. Identity loss. For any proposition P, first one, PRF naught. F naught is nothing but false. Okay. PRF naught is logically equivalent to P. PRF naught is logically equivalent to P. Second one, P and T naught. P and T naught is logically equivalent to P. So this is called as the identity law. PRF is always equivalent to P, and P conjunction T is always equivalent to P. Fourth one, inverse loss. Inverse loss. For any proposition P, PR negation of P is logically equivalent to P. PR negation of P is logically equivalent to P. Second one, P and negation of P is logically equivalent to, can you tell me if P and negation of P, if you take, what will be the answer, whether it is true or false?
True, ma'am.
True.
False. False.
This
False,
is
ma'am.
false. So this has to be F naught. Oh, sorry, this is this, you write it as T naught. P or negation of P. Since it is the disjunction true or, suppose if P is true means this is false. True or false is always true. Similarly, if this is false means this will be true. Therefore, this is also true. So instead of writing T and F, we are writing T naught and F naught. Don't get confused. T naught stands for the truth and F naught stands for the false. So P or negation of P is always true. P and negation of P is always false. So this is called as the inverse law. Next one. Domination law. domination loss. Domination loss. For any proposition P, for any proposition P, first one, PR T naught is always logically equivalent to T naught. Suppose if any truth is there, PR truth is always equivalent to truth. Similarly, P and false is there, means always this will be logically equivalent to false. This is called as the domination loss. Domination loss. Next, commutative loss. Commutative loss. Excuse me. For any two propositions, P and Q, for any two propositions, P and Q, PRQ is logically equivalent to QRP. PRQ is logically equivalent to QRP. Second one, P and Q is logically equivalent to Q and P. For any two propositions, P and Q, PRQ can be equivalently written as QRP. P and Q is equivalently written as Q and P. Taken? Have you taken?
Yeah, ma'am.
Next, absorption loss. Absorption loss. For any propositions P and Q, for any propositions P and Q, PR, P and Q, PR, P and Q is logically equivalent to P. P, R, P and Q is logically equivalent to P. Second one, P and PRQ is also logically equivalent to P. All these laws are to be memorized. They are important. Using this laws only, we will be proving the problems. PR, P and Q is logically equivalent to P. Second one, P and PRQ is logically equivalent to P. We call this as a absorption law. Next one is De Morgan's law. De Morgan laws. This is also an important law. For any propositions, P and Q, for any propositions P and Q, for any propositions P and Q, negation of P or Q is logically equivalent to negation of P and negation of Q. Negation of P or Q is logically equivalent to negation of P and Q. Second one, negation of P and Q is logically equivalent to negation of P or negation of Q. Till what time you will be coming to the classes? Huh? By 2:05, everyone should log in. Negation of P or Q is equivalent to negation of P and negation of Q. And negation of P and Q is logically equivalent to negation of P or negation of Q. Ninth one. Associative loss. Associative loss. First one. PR QRR is logically equivalent to PRQ R, just a moment, RR. Associative property. So you all know this property. Associative commutative is well worth known to you. Similarly, P and Q and R can be equivalently written as P and Q and R. For any three propositions, P, Q, R, PR, Q, R is always equivalent to PR, Q, R. Similarly, P and Q and R is equivalent to P and Q and R. Over?
Yes, ma'am.
Yeah.
Next, 10th one. Distributive loss. Distributive loss. Distributive loss. For any propositions PQR, for any propositions PQR, PR, Q, and R is logically equivalent to PRQ, PRQ, and PRR. This is called as distribution. Second one, P and QRR is logically equivalent to P and Q, R, P and R. For coming to the next class, what you have to do is in a sheet of paper, in a separate sheet of paper, you have to write all these laws and keep it with you. So it will be very helpful in doing the problems. Throughout this chapter, we will be using this. Have you taken?
Yes, ma'am.
How about others?
Yes, ma'am.
Ma'am, can you please turn the previous page, ma'am?
Which law you want to
The-
write?
First three laws, ma'am.
Over.
Yeah, ma'am.
Next, take down the problem. State and prove. State and prove De Morgan laws. State and prove De Morgan laws. State and prove De Morgan laws. Okay. So, what is De Morgan's law? You have already written the statement.
Yes, ma'am.
Tell me.
Negation of PRQ is equals to negation of P and negation of Q.
You should spell it as equivalent, not equals. Okay. So always it will be equivalent, not the equal. So write down. We have by De Morgan's law. We have by De Morgan's law. Negation of PRQ is logically equivalent to negation of P and Q. Similarly, negation of P and Q is logically equivalent to negation of P or negation of Q. To prove this, let us prepare the following truth tables. To prove this, so down you can prepare negation of P and negation of Q, negation of P or negation of Q. Construct the table and check whether they are same or not. Quickly. Check out quickly. So your negation of P R Q should be equals to negation of P and negation of Q, and negation of P and Q should be equals to negation of P or negation of Q. Do the problem quickly. Are they one and the same? Are they one and the same?
Yes, ma'am.
How about others?
Yes, ma'am. Done, ma'am.
Okay. So next, similarly, next problem, state and prove distributive laws. State and prove distributive laws. So now you are having De Morgan's law. Next you have to state and prove distributive laws. So anyways, distributive laws are ready with you. So write down the statement and then go for the truth table. So in the truth table, what you will be writing P, Q, R, then Q and R, P, R, Q and R. Then you will be writing P and this Q, R, R. And you will be showing their equivalent to P, R, Q, P, R, R, and so on. So your truth table must be containing P, Q, R. Then if you can do it directly, you can find out P, R, Q, and R directly. Or if you can't do directly means take P and R and then you do it with the P. So it's up to you. Similarly, P and Q R are then P, R, Q, P, R, R, P and Q, P and R. So in the next line, you have to do P, R, Q, and P, R, R. Similarly, P and Q, R, P and R. Construct the tables having these propositions. Do it quickly. Do it quickly, guys. Over. Guys, are you doing?
Yeah, ma'am.
Yes, ma'am.
Done, ma'am.
How about others?
Done, ma'am.
Those who have done, just raise your hands. Over? Only 1, 2, 3, 4, 5. Only 5 of you. How about the rest of the class? I'll ask you to turn on the video from next class because I won't be knowing what you will be doing. So from tomorrow's class, you have to turn on your video and then you have to listen to the class. So that I will be keeping an eye on you. Now, though, I don't know who is doing what. How about others? Only 9 of you have finished. How about the rest of the class? I'll ask you to send the picture. Now one deleting. Huh? Okay, next. Law for the negation of a conditional.
Ma'am, can you repeat?
Law for the negation of a conditional. Law for the negation of a conditional. Given a conditional, P implies Q, given a conditional P implies Q, its negation is obtained by it to P and negation of Q. Negation of P and Q is logically equivalent to P and negation of Q. Let us prove this. Let us prove this by preparing the following truth table. So we need to check whether negation of P implies Q is equivalent to P and Q or not. So for that, you have to prepare PQ, P implies Q. Negation of P implies Q. Then I want negation of Q. Then you can go with P and negation of Q. So what is this? 0, 0, 0, 1, 1, 0, 1, 1. So this is 1, 1, 0, 1. So this will be 0, 0, 1, 0. So negation of Q will be 1, 0, 1, 0. And then check out what is P and negation of Q quickly. What is P and negation of Q? 0 and 1.
0, 0,
Zero.
1, 0.
0, 0 and 0, 0. 1 and 1, 1. 1 and 0, 0. Now, just check whether this column is equivalent to this column or not.
Yes, ma'am. It's equal.
So just conclude it. We know that fourth and sixth column are having the same truth values. Hence,